Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green.
I'm Leslie Richardson.
And we're here with Phil Japixi.
Hey, greetings.
Continuing our series on automated software testing. In the previous episode, we started looking at mocking, and we're going to continue that.
Yeah, we did a real glancing blow, kind of some of the concepts and things like that. And what I thought might help is to put it all together. What I've been showing is how you do certain things, but we didn't get into the why or how you'd plug it into real code.
Yeah, so I got to admit that in that previous episode, I kept trying to wrap my head around how you would actually use this in real live tests, because I think you said you did a lot of showing the framework, but we didn't actually test anything in the previous episode.
Yeah.
So,
and I've got a bunch of samples where we test things, but it's also trying to teach concepts. So what we have here is a really bad business example where I've got a method called get customer status, right? It should be character status. And if it's Fred or Barney, it's going to return father. If it's Betty and Wilma, return mother. If it's Pebbles and Bam Bam, returns child. And if it returns Slate, it returns boss.
okay.
And anything else, which is impossible because there
Can't believe
is...
you left Dino out of this, but that's
I did
okay.
left Dino out of that. Well, that would be unable to locate status, right? So we're really, okay. Sorry. Anyway, so what we want to do is we want to test that we're returning the right type, right? The right enumeration based on the value, okay? But we don't want to keep calling into the database to have to set up these things, right? We might not even have a database yet because that's a different team delivering that.
Yep.
But we want our business logic to work. So how will we test this? Well, let's first test the happy path. And this isn't all of them. But let's say that I have, unpin. So here's my inline data. Fred, I want to return father, Wilma, mother, and Pebbles, child. So I am mocking the repo to when find is called, it's going to return the customer with the particular ID that I'm pointing to my screen, which doesn't really help. There's the ID, there's the name, right? And then we're going to test our logic and we're going to assert that the status that I am expecting is the status that I'm getting from my system under test, right? The repo isn't being tested. The repo is a vehicle to provide data, okay? So if we run this, we're green, okay? Now let's test the unhappy path. And we're going to pass in the Grand Poobah, right? The head of the Order of Water Buffalo, right? And
I don't remember any of this.
you don't remember any of that?
Nope.
I actually remember to cheer, but I'll save everybody and not do it. But we want the repo to throw an exception.
Okay.
That we don't have the Grand Poobah in this system. And how does our system handle exceptions? And right now, I will tell you our system handles it poorly. All it's doing is throwing. Okay. And we're going to advance this a little bit in just a minute. So when I run this, what I am doing, again, I'm asserting that this method threw an exception. And the exception returned, I'm going to assert that the messages are equal. Okay? Because I'm telling the repo what exception to throw with the message. So when I run this, it passes. Okay. So what do? I didn't do a whole lot, but let's say that we had error handler. And error handler, you know what, it's going to make a new class. Let's just do here. Public interface error handler, and it has a void handle it. And we're just going to keep it really handle it. There we go. Okay. And what we want down here is our error handler to handle it. Okay. So this is our business logic. Horrible, but it's demo code, right? Well, now we have to introduce another mock, right? Because our constructor is going to fail because we're now expecting 2. So we'll duplicate this, and this is error handler, and that's mock. And just by convention, I always name my mocks with the startup word mock. There's no requirement to do that.
Makes it easier to recognize, though.
It does. So here's my error handler, and then we're going to pass in the mock error handler. Oh, we need a comma in there. We still need a comma in there. Mock error handler dot object, and then here we don't have to set anything up because it never gets called. Okay. The other thing that we want to do is, and I forgot to do this before, so we're going to say mock behavior dot strict. So we want to make sure we don't have any side effects. Okay. So let's run these tests. This one will still pass because there's no error condition, right? But we run the test that actually throws the exception. We're going to get a failure. And why did it fail? It failed because it doesn't want to tell me why it failed. No, I just need to click on here. Because I have a strict mock,
Okay.
right? So my error handling method was called appropriately, but I didn't set it up,
Got it.
okay? So then what I would want to do in my code is I would then say, oh, you know what? In addition to that setup, mock error handler dot setup dot handle it, and there's no return value, but we are just setting up that it got called. And we run this, and now it passes
Okay.
because we have an arrangement.
Got it.
Okay.
All right.
When we get into verification, we're going to go even farther down the path of what we just showed.
Okay.
Okay. So does that wrap it up for you?
Yes. That's
Very
good.
high level?
Yep.
Okay. All right. Let's dive into more samples. So we left off with properties, and this next thing actually ties perfectly into what we were just talking about. And it's verification of your arrangements. Right? So it's one thing to mock it, and the strict mock, as we discussed, will verify whether something was set up or not, right? And whether it was called or not. But what if you have something that should be called twice, or should never be called twice? We can also set that up and verify the number of times something was called. So let's look at a very simple example. And we want to, well, let me back up. There's 2 ways that you can verify a mock. You can mark the setup as verifiable, right? And that's where you would actually, after your setup, you call verifiable. And if it fails to verify, then this is the message that gets shown out. Now, one thing I'm doing here, I just want to show you, is I am replacing the actual setup with an expression, because when you call verify, you have to pass in the expression you're verifying.
Okay. So
Right.
verify is testing for just whether or not the method even ran or got
You're
called.
verifying the arrangement.
Okay. So
Right.
that can be whatever, depending on what you're.
Well, so words matter, so I was being very careful in how to answer it, right?
Okay.
So at a very high level, yes, you're verifying that it ran. But you also verify it didn't run, right? Because I could also say, I want to verify the call that it never ran,
Okay.
right? Which you can do with a mock or a strict mock, so you don't have to do that.
Mhm.
This is saying I want it to run exactly 5 times. Or, and I never do this in real life, but I just want to show that you can do this. You can call a method to say, oh, it should have run this many times, right, to determine it. But the verifiable is, I add that on always, but you don't really need to call verifiable, and here's why. If you don't care about how many times something was called, you can just call verify all. And here I have this throwing an exception because it wasn't completely verified. But instead of doing verify for each call, I can say verify all, and it'll verify every setup on the mock. Now keep in mind it's a combination, right? So if you're using a strict mock and something that's called that wasn't set up, you're going to get that exception. And what we're verifying here is the behavior that it was called. right? And if you're just using the verify all syntax, it could be called as many times as you want. So let's go back to our other example. Let's put it into perspective. And we're going to add this up here. Okay? And you're saying, wait a minute, Phil, that's not supposed to be called. Well, you're absolutely right. It's not supposed to be, and we want to verify that it didn't get called. So the way we would do that is we go down here and we say verify times never. And we run this code. We know for a fact it didn't get called because the error handler shouldn't get called because we don't have an error condition. Now, where the times comes in handy is, we got all these great refactoring tools in Visual Studio, and sometimes it gets a little crazy, as we've seen. So let's say that we want to make sure it only handles the error once, but I inadvertently down here duplicate it. It's not going to affect the return value, right? Because I'm still returning an exception, right? But maybe that's an expensive call. Maybe that's writing to disk and it's writing to SQL Server. And it's doing a whole bunch of different logging and sending emails. We don't want to do it twice, right? So we want to verify it only happens once. So now when I run this test, it fails because it said expected one invocation, but two happened. Now this is vitally important if you're doing anything that is expensive, right? That might not affect the outcome. I mentioned in an earlier episode the scenario where the bank was doing the get all inside the loop, and so it was getting called exponentially more and more times each time they were in the loop, right? Well, they only needed to call each of those methods once. So if they would have set up a mock to verify that it only happened once, they never would have called me. Because it would have shown that, oh yeah, you're calling this 9,000 times.
Okay, so you can use this in an example where you're bringing back a bunch of data, populating a list, and there are occasions, depending on where you put that code, where it can run multiple times, and now you're just making a call to the database to receive, or to a service, to receive the same data more than once. So this would be a way to test if that's happening.
Yeah.
Right?
Yep, absolutely.
Okay.
And it's...
Without having to debug and step through over and over again. Oh, that's cool.
Because again, if you think about it, if you call the database twice and you're getting the same list, it's not going to affect the flow of your function.
Right.
Right? It shouldn't, right? Unless there's a timing thing going on between the two different calls. Right? So from an output or even a UAT, user acceptance testing, or QA standpoint, it worked.
Yeah.
It just happens that you're paying twice as much to Azure because you've doubled the call, right, in that chance, or you're just crushing memory.
Yeah.
Right.
Cool.
So that's let me get this. I get twitchy when things are red. So let me fix this. So that's verification, right? I'm going to skip over exceptions for now. I'm going to talk about arguments. So we were calling find on the repo and we're passing in an ID, right? So what happens if the argument doesn't match? So let's say that I have this set up. I'm expecting my customer to be Fred Flintstone with an ID of 12. I am setting up my mock to call find with the ID of 12. Okay, it's very explicit. But I actually call my system under test, the controller, get customer with ID plus 1. And then so what happens is the mock says, oh, I don't know what to do. I'm just going to consider myself not set up, and I'm going to return null. Because you told me to only return this customer if you pass in a 12.
Oh, okay.
Okay? So now you can test additional behavior of your application to say, oh, am I actually calling the repo with the method that was called, or with the property value that was called into the action method, right? Because you could have a bug where you do, right? This is the same thing. Now, I don't know why you would do this, but it's, it's a legitimate bug. And you go, oh yeah, I'm calling get customer, passing in the ID. It's going to call find, getting the ID, but it's still going to return null because I've changed the ID. Okay? And so it's passing because I'm passing for the failure, or I'm checking for the failure, right? Making sure that it's null. Mm-hmm. If you don't care about what gets passed in, mock can handle that as well. What you can do is you can use this it type and say, is any int? Okay? So say, you know what? I don't care. However you call it, return me this customer. Now, I don't like using this in real testing because I think it kind of defeats the purpose.
Yeah.
Right? But there are times where like, you know what? I just want to check to make sure the logging method was called. I don't care about the value being passed in. Right? So that is available to you. We can also do ranges, whether it's inclusive or exclusive. So I can say anything from 0 to 100, right? That's on numerics. I can also evaluate at runtime. Now, again, I don't do this a whole bunch, but it could very well be that it's going to call this method based on the number of records you get from the database. Let's say you're cleaning the employee record. I don't know what cleaning means, but pretend it's a function, right? You can get all the employees. So if your mock employee repo returns 12 employees, then you want to be able to return or have this execute 12 times. If it returns 16, you want to have it return or execute 16 times. So you can actually set it up, you kind of do a lazy load and set it up as runtime instead of value. Now, in the example I just gave, I could certainly just have 16, right? I know I'm returning 16 out of the first mock, so I know it's going to run 16 times in the second mock. But again, it is something that's available to you. But what's better, I think, for complex situations is, let's say that I have a customer that's getting passed into a method, and the customer is getting created, like this method is create new customer. I can't get around in the create new customer method where it's going to say var cust equals new customer. I'm not getting around that.
Okay.
So I'm never going to be able to have the instance mocked that gets returned, right? Because I'm not calling the database to get a customer. I'm making sure that I'm saving the customer. Okay? So then what we can do is we can do this other syntax where we say, and we're using property valuation at this point as opposed to reference valuation. We talked a lot about that in an earlier episode. So what I'm saying here, and let me, it will not let, that's interesting. That's what I was trying to do. So we're going to call add record, and I'm saying it's a customer, but these properties have to match, property values. So the ID is 12, and the name starts with Fred. So then we can actually narrow it down. We know that we're passing in an ID of 12. We know we're passing in the name of Fred. We want to make sure that the repo is saving that record with those values. Right? We don't have access to the instance, right? So we can't say returns customer, right? So then we have to check it out this way. And that is very, very powerful, especially if you're like creating a new logging message and you want to check what the message properties are. Like, what is the error message that you're logging into? And that's typically where we use it. We're creating something in memory, right? And then saving it, like a log message or an email message that goes out to developers when there's a failure.
Cool.
So that's probably good for today, or do you want to go a little farther?
Your call.
No, let's do one more.
All right.
Okay. Let's talk about exceptions. So this is a much more powerful construct than the exception handling in XUnit. So XUnit, you're going to execute a concrete method, and you're asserting that it throws an exception.
Right.
Okay. And that's fine. And you had some questions as to why that would be beneficial. And I showed you whereas demonstrating the mocking framework, it was beneficial, but we still kind of struggled to come up with why is this good in real life? Because your method at the end of the day, none of your methods should be throwing an exception, right? They should be at least captured at some point and not bubbling up, right? Because we don't want to use exceptions as business logic.
Right.
but we know exceptions happen, and we know we have to handle them so they don't get thrown up the ladder. So what we do is we can set and we show this in the business example, we're going to say, hey, this method, instead of doing a typical setup, where we're saying, hey, we're going to return this value, or it's a void method, we don't return anything, we're going to say, you make this call, throw in an exception, right? And then we can get fancy with that. But really, the thing that we care about is this syntax right here. So when find gets called with that particular ID, throw an exception. So you could actually have it call find with 1, 2, 3, 4, 5, nothing happens, calls it with 12, throw an exception.
Okay.
Now you can set your other mocks up to say, did it throw the exception? Was the exception handled? Did we call the error handling object, right? The handle it method on that. And I think really there's lots of other syntax. So if we want to check a getter throwing exception, which by the way, if your getter is throwing exception, you've got bigger problems than how to mock it, right? And the same with setters, right? So we can also set them up, no pun intended, to throw an exception when a setter is called, right?
Okay.
But again, if you're finding that happening in your application, you should probably fix that problem.
Yeah.
But we do understand that no code is perfect. Exceptions happen for a variety of reasons, and we want to make sure we're gracefully handling it, and mock allows us to do that.
Cool.
So is
All
that
right.
good for today?
Yeah,
Yeah.
it's
All
good.
right.
Good for this episode. This is really starting to come together well.
Well, good.
We're going to do one more episode on this.
One more episode on this.
Which is coming up next on Visual Studio Toolbox.
See you soon.
See ya.